Hey everyone, my name is Theresa Quick and I am from Novamera. So what Novamera is doing? So what if we could mine differently? What if instead of focusing on large-scale mines, we could instead think about the smaller deposits that exist around the world? What if we could use conventional drilling equipment for a low capex solution, small environmental impact, and a small footprint? If we could do this, we could take advantage of the thousands of smaller deposits that exist around the world that are currently too small for conventional mining. They either require too much waste with an open pit, or they require too much infrastructure using conventional underground mining. Again, open pit doesn't make sense for these, particularly for steeply dipping narrow veins, and underground requires far too much costly development and capex. Novamera has developed the hardware and software solutions that work with conventional drilling equipment to be able to economically mine these deposits. It's a combination of our guidance tool, our AI, ML, and algorithm software, and our smart drilling system, which includes a position control system and a course correction device. So how does it work? It's a cycle, a surgical mining cycle, closed loop system. So the first step, and you can see here, this is a steeply dipping and narrow vein deposit here. First step is to be able to generate a mine plan, a surgical mine plan, to be able to find out where to economically place those production holes. And then the next step is to use our guidance technology to be able to know exactly where that ore body is at extremely high resolution. I'll just skip to these. So we've got our economic model that provides that information about where to mine to get the most economics out of that deposit. When we place those through, the next step is our guidance technology, which uses hardware and software. This is deployed on a standard NQ-sized diamond core rig. And as it's going down, it's mapping that deposit in extremely high resolution in real time. And what you're able to get is a very detailed idea of the geometry and the continuity of that deposit to be able to adjust where that large diameter drill is going to be extracting. And so what you're then doing here is you've got your positioning control system, which is making sure that that drill is in the precise location for the optimal trajectory. And you've got our course correction device at the bottom that is predictively steering to be able to ensure that you're staying on the ore and reducing dilution. We then use a reverse circulation with airlift assist to be able to bring that material to surface very, very quickly and efficiently. So what are the benefits of this? Well, you now are able to unlock very, very profitably these smaller deposits that often exist on the periphery of existing mines. They can be standalone, but they are everywhere. Very low project risk and very low capital required. You can also reduce your timelines because you're really reducing the development time with a very scalable, modular, and mobile solution. And lastly, you're radically reducing the time for permitting because you're reducing that environmental footprint, you're reducing the community buy-in, and you're reducing the amount of water you're using, and you're radically reducing the waste. So where are we with our MICA projects? So we have two commercial customers that we're currently working with, both in Newfoundland. And this is sort of showing our kind of gradual process moving towards surgical mining. So the first step is our economic evaluation. This is where we're determining the economics of the project to make sure the juice is worth the squeeze. So this is where we find out all the details about what that project is going to look like, including the cost per ton and the capital required and the timelines. So we've completed that with our Great Atlantic project. And then we're moving into our second phase, which is our guidance deployment. And this is when we actually bring our guidance tool and we deploy it at site. And so we're currently in the field with Maritime for our phase 2 of our guidance technology, and we're moving in August with Great Atlantic. And lastly, we're doing a full bulk sample coming up in first quarter of 2025. And what that will do is show the entire surgical mining process happening to be able to extract material using this process. So our project kind of has these two phases. The first one is with Maritime, again, to really show the guidance campaign and show what our imaging tool can do. And the second one includes that entire cycle. So why is the guidance sort of a unique part all on its own? It's because our guidance technology is able to increase the visibility range to be able to get a lot more information about the geometry and continuity. So that information is incredibly valuable because oftentimes, as you can see on the left, conventional delineation methods are a little bit off in terms of those deposits, particularly for veins that are quite they move a lot and they're very complex. This is exactly what we're doing with Maritime. They have a very geologically complex deposit with a lot of parallel vein structures. So we have to date completed our first phase in May with 12 imaging holes totaling 350 linear meters. And then our next phase is actually right now. So we're in the field in Newfoundland currently, where we're going to be doing additional imaging. When this is complete, we're going to be able to generate a 3D ore body model of what they have to be able to compare it to their conventional model that they have. Our Golden Promise property in Newfoundland, we've just completed the economic model, and we're moving forward with our imaging drilling in August. So we've just completed in the process of the permitting process right now, and we're going to be going back in the field with them again July and August. And that, I think I did that really quickly, but if anybody has any questions.
I have 2 questions. What kind of cost per ton are you targeting?
That very much depends on the project, and that's part of that first sort of economic evaluation where we take in all those factors. We're looking at roughly 120 US per ton.
And what's your maximum depth?
300 meters is the maximum depth of the drills. So again, and that's just, those have been drills that have been tested over and over again to that depth. But our technology potentially has those are just conventional drills, so our technology kind of bolts on and works with those.
So enough air pressure to like...
That's exactly it. It's a reverse circulation with airlift assist to be able to bring it to surface. So there's other methods to be able to do that. But that 300 meters is sort of the tested limit of that process.
You'd be able to use it from all existing underground spaces then go deeper then?
Exactly. So you can. Again, every project is slightly different. So any conversations sort of we have as we go with different customers. But the guidance technology makes a big difference in being able to get that additional visibility. And we're also commodity agnostic. So what we're doing is we're identifying the changes in lithology. So we're working currently with 2 gold projects, but we're also looking at many, many other projects within particular the critical mineral space.
What about water? Is that a concern?
So we actually recycle the water using a closed loop system, so with very little discharge into the environment, which has been a huge benefit from a permitting perspective. And so what we do is, depending on water availability, you can bring in the amount of water, and then that first amount of water is put into the hole, it's flushed up, and it's recycled through that cycle.
What do you do for backfill?
So we're using a combination of the tailings, like a paste fill, to be able to backfill the holes as we go. So that process stabilizes the ground, and it also allows us to overlap if we need to, depending on the grade.
You've got a company connected.
Okay, perfect.
Awesome.
Perfect, thank you very much.